that. Hydrogen reacts with iodine to produce hydrogen iodide. Okay? Now, if we're doing this, what we're going to do is to use our backgrounds in understanding chemical formulation to be able to write this correctly. So when we say hydrogen, what form do we expect hydrogen to occur in?
Plus 2.
H2, not plus 2, but H2, because it's a Hankel-Briff. And so our first entry would be H2 plus iodine, I2, because it also is a Hankel-Briff, and it makes hydrogen iodide. So now we have to ask the question, what is the correct formula for hydrogen iodide? Remember, in dealing with these chemical reactions, your first job is to write correct chemical formulas. If you don't do that, there's little hope of balancing it correctly. So we have to have the correct formula. So what's the correct formula for hydrogen iodide? Hydrogen is a +1 type of ion. Iodine, a -1 type of ion. How do I know that? I'm looking at the periodic table. In order to become like a noble gas, iodine must gain an electron. So if hydrogen is +1, iodine is -1, the correct combination would be a 1-to-1 combination. Now I've done my first job. I've written correct chemical formulas. My second job is to balance. So, is it balanced? What would I do? And now we have a balanced chemical reaction. So, why don't you try the second one? Calcium carbonate reacts with hydrochloric acid. Now, we didn't do acid names, and I'm not expecting you to know what that is, but I'm telling you what it is. Hydrochloric acid, HCl, is the hydrochloric acid, to produce carbon dioxide, calcium chloride, and water. So, write out the symbolic form and make sure it's balanced. Go.
What is it, HCl? Okay.
I'm sorry?
So you might as well be speaking French.
Well, we should talk.
Do we have to know the charges? Or just...
Yes. If you're going to write correct formulas, you have to know the charges.
I mean, like... So, I mean, do I have to put CO3 -2?
Not if you're writing a neutral chemical compound, no. Remember, chemical compounds are neutral, and we combine them in such a way as that you don't have a charge on them.
Right. So, is this correct as far as the chemical?
It is not. You have a mistake.
Okay.
Is it balanced?
No.
Dr. Brown,
Yeah.
when we're doing this, like, does this mean this reacts with this to produce this?
No, that means that this produces this. This should just be a plus sign.
Oh, plus. Okay. Now there's...
Now you just gotta get it right on the test.
That would be nice. What is calcium carbonate? Oh, what is calcium carbonate? Can you write the formula for it? Psst, oh, there's the buzzer. So calcium carbonate should be CaCO3. Calcium is a +2 carbonate, -2. How did I know that? It's a memorized polyatomic. So they combine in a 1-to-1 ratio. They're reacting with hydrochloric acid, which we're told is HCl, and it produces, so there's our arrow, carbon dioxide, that'd be CO2, and calcium chloride. Calcium's a +2, chloride -1, so it's got to be CaCl2 plus water, H2O. So we've done our first job. We have written correct chemical formulas. Our second job is to balance. Is it balanced? What would I have to do to get this to balance?
Put a 2 in front of the HCl.
Does that do it?
Yep.
I think it does. So we've got to follow those 2 steps. So let's try the third.
Thank you.
Go ahead, take 12 seconds, try to get the third one done.
You put the 2 in front of the HCl?
I did.
Okay.
Why do we do that again?
I'm balancing. So when I look at this side, I have, without the 2 there, I have only 1 hydrogen. But on this side, I have 2 hydrogens. So I've got to bring that into balance.
Perfect.
Was last year the highest one that we're gonna do?
It varies for different people, depending on how good they are at math, how not good they are at math, how much they study.
Person.
You are?
I'm not feeling as lower than the first one.
Well, the third one has more math in it.
I got most of the multiple choice, like most of the writing down. I got all of them right except for the one with the write down. But the multiple choice is where I had.
Well, we can talk. We can look at it.
Okay? So iron 3 chloride, what's that 3 telling you? Iron's a +3, chlorine. So it must be FeCl3. We're combining that with metallic sodium, which is just Na. We are reacting that, and it's going to form sodium chloride. Sodium's a +1. Chlorine -1. So we get sodium chloride plus iron, which is Fe. So there's our correct formulas. Now we have to balance. 3 here
3 in front of the N.
and 3 here. And we're done. It's a good thing. Okay, section 5.3 of your textbook, page 140. You can skip it for the time being anyway. We're going to come back to it later, but not as aggressive as the book does it. We're going to look at it from a slightly different, easier point of view. So we'll skip that for now. But that brings us up to what we call reaction types. And you can imagine that we have 115 elements. We have close to 50 million known chemical compounds, there must be a lot of chemical reactions out there. Our hope of understanding each and every chemical reaction is probably beyond the scope of our course. So what we try to do is we try to simplify things when we can. And one of the ways you can simplify things is to type them or to put them into groups. Biology tends to do this. I don't know much about biology, but they tell me that biology has things separated into what are called kingdoms. You have a plant kingdom and you have an animal kingdom. And inside the animal kingdom, the animals are broken down into various groups. You have mammals, reptiles, insects, birds. I think those are different. I don't really know, but you get the idea. We separate those things into various groups that have some common characteristics. Well, we're going to try to do the same thing with chemical reactions, is we're going to try to take those chemical reactions and classify them as a particular type so that we understand the characteristics of that chemical reaction. And this won't get us anywhere near all the chemical reactions, but it will get us through a lot of chemical reactions so that we can understand what they are. We are going to talk about 4 types for sure, and we'll mention 2 others. And so we'll take them one at a time. So the first type is called a combination or synthesis reaction. Sometimes it's called direct combination. And what I'll do for each of these types is give you sort of a dummy representation of what's taking place. And then we'll look at specific examples and see how it applies. So, kind of as the name implies, the dummy representation says that we're going to take some substance A with some substance B, and we're going to combine them together into one substance, AB. Now, the thing to do with these types of reactions is to look for certain clues, certain cues that will allow you to say, this is this type of reaction. And the way you can recognize a direct combination is that there will be one product. One product. Remember what products are. The right side of the arrow. The left side of the arrow are called reactants. So there'll be one product. Now there might be more than 2 reactants. Conceivably I could take A plus B plus C, but one product will be the direct combination clue format.
So Na plus Cl, and the product would be NaCl. That would be
close. Na plus Cl2. Why Cl2? It's a Hankelbrief. And in natural conditions it exists as Cl2. Now, if we combine those together into one product, what will that product be? Well, it's got to be a compound made from sodium and chlorine. So let's go back a couple of weeks to the point where we said, what if I was going to make a compound between sodium and chlorine? How would I do that? I would analyze it as sodium is a +1, chlorine is a -1. The correct combination would be NaCl. So, here's a good example that shows we are still following the same format. Your first job is to write correct chemical formulas. First job, write correct chemical formulas. Now, are we balanced?
No.
We worry about the balancing after we've written the correct chemical formulas. So, what do you suggest we do to balance this?
2 in front of NaCl, 2 in front of Na.
2 and 2. Like so. Look how it relates to the dummy representation. We've got a substance A plus a substance B coming together to form one product. So this would be a direct combination reaction. Sometimes, like the sodium chloride question we just did, you'll be asked to form the product. Sometimes the product will be given to you, and it's only there so that you will balance it correctly. So, first of all, recognize, is this a synthesis reaction?
Yes.
Yeah. So it doesn't have to be elements that come together. It could be compounds. Two small compounds come together and make a bigger compound. So SO3 plus H2O makes H2SO4. Direct combination because we have A plus B equals AB, something that's combined together. Now, are we balanced? We are. Will that happen occasionally? Yes. How about this one? You want to try it? Okay, product should be
2HF.
HF to get the correct formula. And to balance, you need a 2. How about a tougher one? Nitrogen plus hydrogen. People are stuck.
NH2.
No, nobody. Oh, one person. 2 people. Okay, let's talk about it. What are we going to do? We're going to do a direct combination reaction, which means what? Your product should be made out of nitrogen and hydrogen. Can we write a correct formula for a substance that's made from nitrogen and hydrogen? If nitrogen is going to be in a compound, what kind of charge would we expect it to have?
Negative.
One of those two.
Because hydrogen
Be
is
more
positive.
specific though. Negative or positive what?
3.
Negative 3. Hydrogen plus 1. So if I'm going to put those together,
NH3.
what will the formula look like? NH3 or H3N.
Yeah, that's
H3N
right.
is more correct. NH3 is the customary way to write ammonia. Either way would be okay. Now we've done our first job. We have written a correct chemical formula. Our second job is to balance. Can we balance this?
Put a 2 in front of the NH3 and a 3 in front of the H.
So we suggest a 2 here and a 3 here. Does that do it? I think so. Okay. Second type of chemical reaction. Decomposition. Let me give you the dummy representation of this type. This type says that if we have a compound, we can break it down, that's what decomposition means, into smaller substances.
Now, which one would be the product? Which one would be the reactant?
Products are always on the right. Reactants are always on the left.
Okay.
So, what's going to be our clue to understanding and recognizing decomposition reactions?
If you break down,
One reactant.
Hold on, you just said products are always on the right and reactants are on the left, right?
Yes.
So this is backwards from that, right?
no, the product is.
What do you mean?
Products are always on the right, reactants are always on the left, right? No, just-
Yes, but you're pointing to the wrong.
what is this right here? Does that go with number one or does that go with number two?
This is number 2. This is a decomposition reaction.
Products always on the right.
Yes.
Okay, so
A.
that's different from number one though, right?
No, it's not. Your products are on the right.
This becomes a product.
And these are the reactants.
I'm confused, that you just switched those around.
Yes, they're opposite reactions from each other. But in one case, something is the reactant, in the other case, something's the product.
But
Because-
either way, they're both always on the right, is what you just said.
What's always going to be on the right?
Product is always,
Product is always on the right.
okay.
Absolutely. So, what's the product in this dummy reaction? A and B. What's the product in this dummy reaction?
AB.
AB. So they change their roles depending upon where they're located. So we have a breakdown of our substance into smaller substances. Now, I think it's a little bit difficult for you to recognize what should these things break down to in all cases. So unless I give you some kind of a hint, I'll probably give you the products and ask you to just balance. But here's a case where I wouldn't. If I said, here's H2O, and it decomposes into its elements, there's a big enough clue for you to be able to write this result. So water breaks down or decomposes into its elements.
This H plus O?
H2 plus O2.
H2 plus O2.
Because it brings
Remember, these guys are Hunkelbriefs. And so they're going to form diatomics. So the product here is H2 plus O2. And again, I've performed my first task, which is to write correct chemical formulas. What's my second job?
Balance the equation.
Balance the equation. Is it? Yes.
Why is, okay, so why is it also? Okay, I got it.
Okay. If we remember Hunkelbrief, we know the 7 that will always occur as diatomic. And we have to constantly mentally check that when we're doing these reactions. Other questions? No?
What was the clue?
In the case of decomposition, there'll be one reactant. One reactant. Just the opposite of direct combination or synthesis.
Isn't,
Yeah.
is that also called single?
No.
Okay, that's a different kind. Okay.
Okay, are we balanced?
No,
What can I do?
put a 2 in front of the H2O and a 2 in front of the O2.
Okay.
Why do we do this? Why do we do this? Like, I know what we're doing. Lost.
All right, recognize the type. Is this decomposition?
Yes.
Okay. Is it balanced? I've already given you the reactants and products, so your first job is done for you.
Oh.
If it's not balanced, what would we do?
Yes, it is.
Tup, tup, tup. It is balanced. All right, good job.
Oh.
Is it decomposition?
Yes.
Yes, it is. Is it balanced? Yes, ma'am.
I'll put the same way.
You got it?
But she
Two right there, and two right there, and then three right there.
Okay. Do we agree?
God.
Try another? You got an answer? You got one?
a 4, and a 4, and a 2 with an H2.
Does that work?
Is there like a method
Why
that you
won't-
use, or do you just, is it checking that?
Trial and error, back and forth, back and forth.
Can you go over that one, like,
Hey,
just
I
from
didn't
how
see-
you would do it, each
Okay.
element?
What do you have?
I just did 2, and then 2, and that's it.
All right, let's check it out. How many hydrogens do you have here?
2,
How many do you have here?
2,
Okay. How many nitrogens do you have here?
2,
How many do you have here?
2,
Okay. How many oxygens do you have here?
6. Oh, okay. 4, 5, 7, okay.
That one balanced.
Okay.
So if we were doing this, an approach would be to say, all right, well, let me start with something. I usually am told to leave hydrogens and oxygens go to last. I'm certainly going to leave the oxygen go to last here because it's in multiple spots. The hydrogen is localized into just one place, so that helps. But I'll start with the nitrogen, and I have one on the left and one on the right, so I'm okay with nitrogens. If I go to hydrogens then, I have one on the left and 2 on the right. And that means I need a 2 here. And if I need a 2 there, if I go back to the nitrogens, then I need a 2 here. And so I have 2 nitrogens, 2 nitrogens, 2 hydrogens, 2 hydrogens, looking very promising. I have 6 oxygens, but as we saw just a second ago, we have 4, 5, 7 oxygens here, which means we need more oxygens on the left. So let's just characteristically bump this up by 1, see what we get. Now I've got 3 nitrogens, so I have to change this to a 3 to get 3 nitrogens. I have 3 hydrogens, but here I have only 2 hydrogens. So I'm going to have to increase the amount of hydrogens over here. By putting a 2 there, that's going to change this to a 4, and that's going to change this to a 4. So I've got 4 nitrogens, 4 nitrogens, 4 hydrogens, 4 hydrogens, 12 oxygens, 8, 2 is 10, 2 is 12. And we're there. Our third type of chemical reaction is something we call single replacement. Single replacement. Think of what the words are saying. Single replacement. We are going to replace a single component here in the course of the chemical reaction. The dummy representation is to take an element plus a compound and to literally singly replace one of those substances in the compound. So we would end up with something like AC plus B. So look at the form. How are we going to recognize this one? On the reactant side, we have
3.
an element and a compound. That's how we recognize it. An element and a compound. Now, when you do this, it forms an element and a compound. But they're different in the process. So let's take an example. If I react silver nitrate with copper, I get a single replacement reaction. Now I need some help here because it's not immediately obvious what we should get, but we get the copper 2 compound to form. So if we're told that information, copper 2 is the compound that forms, then what will the charge on the copper be over here? Must be a +2. It's a copper 2 compound. It's going to pair up with which one of these guys?
AG.
No.
No.
If it's going to be a positive, it's probably going to pair up with the negative component. And the negative guy here is nitrate. And what's the charge on a nitrate?
-2.
Minus.
Minus what?
-1. So the correct formula must be CuNO3 2. And then if I have kicked out the silver from this reaction, that means the silver stands alone. So first of all, notice the form of the reaction. It's a compound plus an element, and it's reacting together to make a compound plus an element. And something is being replaced. A single item is being replaced. The copper is coming in and kicking out the silver, taking its spot. So we've got the format down. We've got the correct formulas for our reactants and products. Are we balanced? What can we do?
Put a 2 in front of it. AG. And then
Here?
in front of it.
Does that do it?
No, because the nitrite.
Well, let's check it out.
No, that's
How
fine.
many silvers do I have on the left?
2.
How many do I have on the right?
2.
How many nitrates do I have on the left?
2.
How many do I have on the right?
2.
How many coppers do I have on the left?
1.
How many on the right?
1.
Oh, okay.
Looks okay. Yes, sir.
Where did the subscript 2 come from on the product?
The information I'm given that I don't know off the top of my head is that it would say something like copper forms a copper 2 compound. Okay? This would not be something you would be expected to know off the top of your head. Because copper comes to us as either +1 or +2. If I were designing this, if I were God in charge, I would have made it +1. That's a lot easier for freshman students to handle and balance. But remember, what we do is not make up the rules. We only interpret what nature does. So how do I know this is the particular case? Because we've done the chemical reaction. Okay? In fact, I brought it with me, but in the interest of time, we'll save it for next week, and we'll actually do this chemical reaction. And when you do it and you analyze the mix, you find out that this is what you get, the copper 2 nitrate. And so that's what we have to put.
Why did you put it behind nitrate instead of front of the
Well, what does this mean to you? Right. That should mean that the copper is a positive 2. Now, what's a nitrate? -1, right? So I want to combine these together into a neutral chemical compound. What formula will I write so that they represent a neutral chemical compound? It's going to be this. And remember, my first job is write those correct chemical formulas. Second job is to balance. Okay, go. Try this one. First of all, do we recognize the type? It's single replacement, easily. Why? Because it's an element
Plus a compound.
plus a compound.
I don't know.
What's that look for?
Balanced?
Mm-hmm.
Okay.
Is that right?
I think so.
I don't know where to begin. I know that I should have 2 and 1. Like I should
I
have
don't
a
know what that
compound.
means. 2 and 1.
Like I should have a compound plus a single element.
Zinc is +2, right? Yeah, +2 naturally. Mercury is going to be a positive because it's in the transition metals. So if we have mercury 1, mercury 2, whatever it is, it's going to be a plus. You can't mix the plus with the plus. You would want to mix the zinc and the chlorine.
Right, because that's a minus.
Right, and when you mix zinc and chlorine, zinc is naturally +2 and chlorine is naturally
A minus.
-1. So you would want to
Okay.
ZnCl2
Formulas should be
and then plus Hg. And Hg isn't a part of Ringelhoff, so it wouldn't be 2.
Okay.
And then it's hard balanced.
those are the correct formulas.
Thank you.
Are we balanced?
It doesn't matter which one's very good, like HG plus Z.
No. It does matter whether you have a reactant or a product. It does not matter what order the reactants or the products come in. There's no rule for that. So you'll see it a variety of ways. How do I would know what? What's the charge on the zinc? So is he going to pair up with the positive guy or the negative guy? He's going to pair up with the negative guy. Who's the negative guy? There you go. All right, why don't we stop here? It's been a rough day. Hey, if you're coming to see me today, I got to leave at 2 today, so I'm going to have to cut my office hours short by 1.